Good morning, guys. We have a lot of kind of fun things to do this morning. So the first, without further ado, Shane, take the stage, man. Let's see what you got.
Okay. We're going to have a quick discussion on some background, and then we're going to go into sci-fi a little bit. The first thing is pressure. What is pressure? Basic way to say it is, I am exerting pressure on this table. Why is it holding me up? Because there's enough molecules in a certain configuration that we call solid phase of matter. What it's doing is, it's not allowing me to pass through because I'm not exerting enough pressure or in the right shape to exert that pressure. So let me take this apple, Newton's apple, by the way. I'm going to exert enough force, but it's not in the right shape. So it's not going to push through. So it's actually getting enough back pressure pushing it up, so it'll actually stay there, more or less. Now, we do it like that, everybody expects it to go right through it. The same thing we see with water, a liquid. We can't actually sit on it. We will sink right through it. Why? Because we're not in the right shape. There's enough pressure to push us down. So, I need the clicker. You need the clicker?
This one you just
Oh, okay. Wow.
You can use it.
Okay, so these huge, massive things, this thing weighs 200 million pounds. 200, no, I take it back. 200 million pounds. That thing weighs 200 million pounds. Why is it can float? It's because it's in the right shape. It spreads out its weight over a large enough space that it actually the downward pressure is less than the upward pressure. So here's where we're going to go. Now we're going sci-fi. Floating islands. These things are much bigger. Why can they float? Same principle. You've got more upward pressure than you do downward pressure. So now we go to look at something different. Here we're going to float on gas. Sulfur hexafluoride is 6 times heavier than air. So you can actually float something with just air, just a gas. So a gas can hold it up. We all understand how helium can make stuff float. That's nothing new. Now, this is Venus's atmosphere. Everybody knows Venus is the hottest planet we've ever even thought of. I mean, it is way beyond. At the surface, it's over 700 Kelvin. And it's got 92 atmospheres. That's a lot of pressure. But at 50 kilometers, it's 1 bar. This is our temperature scale. It's at right about 300 Kelvin. This room's just under 300 Kelvin and 1 bar. And it has Earth's gravity. So what can we do with this? Well, in another couple of 100 years, we'll be able to do this and have a floating state. We all know the Star Wars. Clicking. Love technology. Without fail, I will have one slide that always does that. No, not this part. Where's my next slide? There we go. Just a picture of it. We've all seen that because most of us have seen Star Wars. Now, how about this? Floating colonies. We can actually do this. How about this? This is actually, believe it or not, this comes from a group, a country that no longer exists. And unfortunately for me, half of you don't even know of it. You guys don't remember the Soviet Union. And that really makes me feel bad. Everybody out here chuckles, so yeah, they actually understand how old that is. This is back from the early 80s. This is 30 years old, this concept to actually go colonize Venus using floating colonies. Because it can float on air. Our air pressure, our atmosphere, the air we need to breathe would actually float in Venus's atmosphere. And I'm just going to quickly flip through a couple of really weird... That's held up just like how we think of blimps today using helium. That's just using air. And these are just a couple of the slides with some really weird looking stuff. I swear the Russians always have great. And that's kind of my presentation for you guys today. Nice job. Any questions for Shane?
saying you want to live on Venus?
I'd like to try that, but I'm kind of more interested in Saturn, which you can do the same thing with Saturn, Uranus, and Neptune.